Welcome to AMS Talks. I'm Rick Bacon, Chief Executive of Aqua Metrology Systems, and I'm joined today by Joshua Webster, Water Treatment Operator for California America Water's Isleton Water System. Today we're going to be talking about a demonstration that we ran at Isleton to demonstrate the effectiveness of an innovative approach to treating for arsenic based on the in-situ generation of reagents to treat for arsenic. Josh, thanks for joining me today.
Hello, how are you doing?
Great. Before we get into the specifics of the demonstration and the outcomes of that, we often end up talking on these talks about the technology, what it does, what it was trying to do, benefits and features. But you know, you're running the Isleton Water System there. Maybe just give people who are watching this a bit of a context of Isleton. For me, it's a very interesting town, and maybe some background about it would be interesting to the viewers.
Yeah, it's a little tiny town right on the Sacramento River. It's about 5 miles north of Rio Vista. So it used to be a big trading hub. It's been around since I think about 1830. So it's got a lot of historical buildings and stuff from about that time and on. So it's been a big agricultural area up until recently. So it's got about 500 or so people there now, population wise, which unfortunately it's dropped a little bit. It used to be about 800. So we've had a little bit of migration out away from the town. But other than that, yeah, it's just a quaint little town, you know, right next to the river. It's great for fishing, especially if you're into river fishing. You get bass, the striper running up, salmon season. So yeah, it's pretty nice.
Great. Well, I visited it 2 or 3 times. It's a fascinating place. I would encourage people who can to visit it. So we visited it actually many years ago because we were originally doing monitoring of your treatment system for arsenic, and that actually sort of gave us the idea, well, if you're monitoring for arsenic, monitoring your treatment system, maybe it'd be a good place to start with our innovation in arsenic treatment. So maybe you could just describe a bit about how you've been treating for arsenic traditionally, Josh?
Yeah, traditionally we have 2 wells on site. We treat the well water with a combination of sodium hypochlorite and ferric chloride with a polymer to help with it. We run it through some basic conventional filters with some green sand in it, and then pump it into a storage tank and then boost it out to the town now.
Great. And what sort of level of arsenic are you having to treat for, and what sort of level are you sending out to the town?
It's on the raw side, it's anywhere from 16 parts per billion to 26 parts per billion, depending on the time of the year and honestly the flow of the river. So other than that, and that seems to be the nomenclature that we see that changes it. It's usually the season. Some season, you know, winter time, it's actually higher, I assume, because the aquifers come up, and in the summertime, it actually, you would think it would condense and get higher, but it seems to get lower. So, but it seems to be right in that range of 16 parts per billion to 22, 24-ish. And then we treat it and try to bring it down. Obviously the MCL is 10. Right now, we're able to get it down to about 6 parts per billion going into the storage tank, 6 to 7 range.
That's excellent. Well, monitoring helps all of that, keeping tabs on it, I imagine.
Absolutely.
So so the system that for those who are coming to this podcast, so what we've introduced, you've been buying ferric chloride in volume, in bulk, and then dosing, as you described, into the water system. And what we turned up with in a trailer was a system which generates the active reagent ferric, which is what removes the arsenic. And that's what my colleagues were on site demonstrating. So when you looked at this system and you were comparing bulk chemicals that you buy in on a fairly frequent basis, I imagine, with this in-situ system mounted in a trailer. Can you talk a bit about how, some of the questions you had about when you were evaluating it, what your concerns were, or what you saw as the process of the pilot unfolded that was of interest?
Well, the thing of interest is actually being able to create the ferrous, if it's possible, on a larger scale, because especially with the pandemic and stuff going on, there's actually been a shortage of ferric chloride. So we were actually having to buy more and store it on site, so we make sure we didn't run out, because there's actually a shortage of it. So if you could actually create it on site, that would be a great benefit, especially in situations like this.
Right.
So that's what the interest was.
Well, security supplies are something we get asked about more and more, because you can store the generator cells on site, as many as you want for as long as you want, and the steel that goes into them is obviously got a very, very long life, and therefore you've got that security of supply. I think one of the other things that makes Isleton interesting is that it's not just arsenic that's in the water you're treating, right? You've got other metals or other contaminants in there, which can make sometimes the treatment system a bit more complicated. And maybe you could talk a bit about that in terms of the co-contaminants that are in the water.
Yeah, so predominantly it's arsenic. We have a little bit of iron, and then manganese is probably the second one. And then we're seeing silica actually in some of the water, which is not helping with the absorption of the chemicals, and it's messing up some of the chemical combinations. So those are the main ones that we're seeing in there right now that we treat for.
And that's of interest to us, because the good thing about technology is it can be very specific, and it can avoid being compromised by particularly things like silica, which I know invalidates a lot of other alternative treatment systems, right? Like ion exchange, for example.
Correct.
Right. So you saw the pilot play out. You saw all the iterations we had, which is the joy of doing a demonstration pilot. You don't know what you don't know until you discover it. But we got to the end of it, and our goal was very much to, in a sense, replicate your whole treatment system, with the exception of the ferric at the beginning. So when we got to the end of that whole demonstration project, sort of replicating your system, what were your conclusions from that in terms of how the system had performed overall, even though it was on a small scale?
Well, yeah, it was on a small scale, but basically, in talking and working with David Jutek there, he was actually able to recreate what we're doing in Isleton on a small scale. So at least it's able to do what we're doing.
Right, right. And that was part of our objective, because I think, a lot of people are using ferric, and what we want to be able to say to them, as one day hopefully we'll be able to say to you and your bosses, we've got a system that is identical in what it's doing, apart from the fact that the source of your reagent now doesn't come in tankers. It comes in steel electrodes that we dissolve. You've got the security of supply, but everything else remains unchanged. And you probably eliminate some storage of having to store these chemicals and handle them.
You would eliminate the storage of the ferric chloride, and anybody that's dealt with ferric chloride before knows that it has a lot of hazards with it. It's very corrosive. So yeah, getting rid of that would be great.
Well, I'm conscious. The health and safety associated with ferric chloride, it's very corrosive, and it's not good to get mixed up with people, right? So that's an added benefit. It's difficult to attach dollars to that, but I think a lot of site operators see that as another advantage ultimately.
Yes, absolutely.
Good. So if you were talking to one of, you're at a conference or one, operators meeting, and you're talking about, they've heard you've done this innovation. Any takeaways that you would give them, plus or minus? Because I want this to be a sort of full disclosure type of conversation.
Well, like I said, pluses right now would be the fact that you're actually able to duplicate what my plant is already doing, obviously on a smaller scale. My only takeaways at this point would be the concerns of the size. Can you get it scaled up?
Right.
And then especially being in California, the electrical cost of having to charge those and make the ferrous from that's my biggest thing. Like, how can you get the metal and then the electricity and the cost of the electricity to actually bring that to fruition?
I'm really glad you raised that, because, and firstly, the system is powered with low power electricity. But more importantly, the system that we are designing for Colorado will be based on renewable energy. So we can use solar power, wind, and there's plenty of solar where you are.
I mean, that's also something that's beneficial to know. I didn't know that.
Right.
Something to look into, because unfortunately, like the power grid in Isleton, I use a lot of generator and downtime when we lose things because of the high winds in the area and things like that. So,
well, and the other thing is that you can generate the reagent and store it. Now, I know we talked about not storing it, but in this case, you could store it for when renewables aren't available. So you could generate more than you need during the day. And if you're dosing 24/7, which I know you're not, but if you were to be, or there's not sun for 2 days, you would have some you'd have storage there to cover and carry on being able to use renewables during that period of time, or off-peak electricity, the same deal applies. So, well, it's great having this conversation, because I learned something and you learned something out of it. So.
Yeah, it is. It's really good.
Great. Well, Joshua, I'm going to come up and see you before too long. I really appreciate your time for this. And giving us access to the site. You've been very patient with us. It's been
no problem. It's been a pleasure. Like I said, we've been working together for a long time using your equipment. So it's been a pleasure.
Well, thank you so much. I appreciate that. And we will talk again soon.
Sounds good. You have a great day.